Welcome to Emergence.
Hi, my name's Rahana, and I'm going to be presenting a NeurIPS workshop paper called Multimodal Auto-Validation for Self-Refinement in Web Agents. In this work, we build a web navigation agent which is able to reach state-of-the-art results on Web Voyager dataset. We built this agent by using a self-refinement process, which allows the planner agent to iteratively correct its plan. In the process of building this self-refinement pipeline, we also build an auto-validation system, and we report our results on that as well. Before diving into those results, I'll briefly talk about this paper Agent E, which is what our agent is built on top of. Previously, Agent E had the state-of-the-art results on the Web Voyager dataset. This agent is a hierarchical system. The hierarchy consists of a high-level planner agent and a low-level planning agent. The high-level planning agent breaks down a task into smaller subtasks. For example, find a lasagna recipe on allrecipes.com can be broken down into go to allrecipes.com, type in lasagna into the search bar, and then find a lasagna recipe. The low-level agent would deal with the fine-grained actions that need to be executed. For example, typing in lasagna, clicking enter, clicking through each lasagna recipe, etc. One interesting observation that the Agent E paper reported on was the self-aware failures. So the failure rate of Agent E was about 26.9% on the Web Voyager dataset, and about 14.1% of those were self-aware failures. So as we can see, the LLM model here is able to identify the failure cases on its own. Inspired by this, we try to build our own validation system, which is a little bit more explicit. So we try out 3 different validation systems, which we report on. The first one using the task log, meaning the high-level planner's chat log. The second one being a sequence of screenshots which are taken after each action. And then the last one being the sequence of screenshots as well as the planner agent's last response. Our results indicate that the task log agent outperforms the other two, achieving a validator accuracy of 84.24%, while screenshots only get 70% and screenshot plus final response get 83%. One interesting observation is if we look at the validator accuracies broken down by each website, it's not clear which validator agent performs the best. So in some cases, we see that the text validation outperforms all the others, while there are some cases where having screenshot or having some form of vision helps. So the places where we see this jump happening the greatest is, for example, in booking.com, we see quite a large jump. We also see a reasonable jump in Google Flights, where vision seems to help. And then we see the opposite result in something like Google, where having some form of text seems to significantly improve accuracy. Now that we have identified that the validator works reasonably, how can we use this validator to improve our planning further? So the percentage we really care about improving is this true negative. So if the validator can identify these negative results, can we improve on them? We propose using a self-refinement workflow, which looks something like this. A task is given, the planner plans something out and executes it, and then at the end we call our auto-validation, and then our auto-validation will either say the task was completed successfully or not successfully, as well as some sort of feedback. If the task was not completed successfully, the feedback is given back to the planner and the planner is able to reattempt the task. To test out our self-refinement mechanism, we run this on the Web Voyager dataset. When we look at our self-refinement mechanism, we see that we're consistently able to have about a 4 to 6% improvement across all types of validators. Between each validation type, we see fairly similar performance, but we do see a jump from the Agent E performance. Again, now, if we look at the breakdown by task type, we see again that it's not clear which type of validation to use. Some tasks, again, perform really, really well with vision. Again, something like Booking.com, we see quite a jump with some type of vision, and then same with Google Flights. And then in some cases, again, we see having some form of text helps, like in Google, something like BBC News or Archive, which are more text-based tasks, perform better with the text-based validator. One reason we saw high performance in tasks like Booking.com and Google Flights is because highly interactive widgets and websites were very difficult for the agent to interact with and understand only looking at the DOM. So we saw anywhere where there were widgets being used, like in Amazon.com, Booking.com, Google Flights, or any other website where there might be widgets, that the performance was fairly low on those tasks. If it was using a text validator but worked really well with vision. The overall conclusion we got from this paper was that we can build a reasonable automatic validation system with an LLM, and it does have some sort of overall improvement it can cause in a web navigation system via self-refinement. Although one thing that's still not clear is which modality of validator to use, and it's not necessarily true that one validator is better than the other. So this suggests that there's possibly a need to have multiple validators which are task specific. We think future work can be done in this direction if anyone's interested. And if you have any questions about this paper, feel free to contact me or razam2@illinois.edu. Thank you.